Here we have AP calculus AB problem. Okay, let's go the information. Write an equation of the tangent line to the graph of y equals to x negative x square that is parallel to the line y equals to 5x negative 3. Okay, there is a formula to find the equation of the tangent line to the graph of the given equation. Let me write the formula. So equation of tangent line. So that is y negative y1 equals to m times x negative x1. So here x1 comma y1 represents a point at where we draw the tangent line to the graph of the given equation, and m is the slope of the tangent line. Okay, now let me sketch the graph of the for the given information. Let me sketch a rough graph. So let's say this is a curve. This is a graph of the given equation. And now let me draw a tangent line to this graph. So tangent line is nothing but the line which touches the curve at some point. So in this case, so the tangent line touches the graph of the given equation at the point x1 comma y1. Okay, and also the tangent line is parallel to another line whose equation is y equals to 5x negative 3. Okay, since the tangent line over here is parallel to this line y equals to 5x negative 3, so both the lines must have the same slope. Whatever slope we have for the line y equals to 5x negative 3, the same slope we have for the tangent line. So because whenever two lines are parallel, the slopes must be equal. And the equation of the line over here is given in slope intercept form, that is y equals to mx positive b. At the place of m, what do we have? We have 5. That is the slope of this line is 5. Then the slope of the tangent line is also 5. So now we got the slope of the tangent line, that is a value of m 5. We can plug in 5 over here, but still we need the point x1 comma y1 at where the tangent line is touching the graph of the given equation. How do you have to get this point x1 comma y1? Here already we got the slope of the tangent line, that is 5. So we got this slope of the tangent line 5 using this information, that is using the equation of the line y equals to 5x negative 3. In case we don't have this information, how do you have to get the slope of the tangent line? For that, what I have to do is I have to find dy over dx from the given equation. That is, I have to find derivative with respect to x. So here in this equation, if I find derivative on both sides with respect to x, so what do I get on the left side? I'm getting dy over dx. So on the right side, what do I get? If I find derivative of this x with respect to x, I'm getting 1. If I find derivative of this x square with respect to x, I'm getting 2x. Okay, so the result of dy over dx, that is 1 negative 2x represents the slope of the tangent line. Already we know the slope of the tangent line, that is 5. So this 5 and this 1 negative 2x, both of them represent the same stuff, that is the slope of the tangent line. Since both of them represent the same stuff, we can equate them, that is 5 equals to 1 negative 2x. Okay, now let's solve for x in this equation. For that, let me subtract 1 from both sides. So this positive and negative 1 will cancel. I'm getting 4 equals to negative 2x. And now I divide both sides by negative 2, then negative 2 will cancel out here. When I divide 4 by negative 2, I'm getting negative 2 on the left side, and the right side I'm getting x. So now I got the value of x. When I equate the slope of 182x, that I get it from the given equation, and the slope of the tangent line 5 from the given equation of line. Okay, so this the value of x I got over here is the value of x1 at the point of contact. So how do you have to get the value of y1? For that, we have to plug in x equals to negative 2 into the given equation. So the given equation is y equals to x negative x square. So let's plug in x equals to negative 2, then negative 2, negative 2 the whole square. Then I'm getting y equals to negative 2, negative. When I evaluate this negative to the whole square, it's just 4. Then I'm getting y equals to negative 6. Okay, now I got this point, that is negative 2 comma negative 6. So once you get the value of x, always you have to plug in this value of x only into the equation of the curve, not in this equation. Okay, and because we are trying to get the point of contact is on the curve and the tangent line as well. So this point of contact is not on this line. So always you have to plug in this value of x into the equation of the curve. Okay, anyways, now we got the point of contact, that is x1 comma y1. Okay, let me write the stuff over here, that is negative 2 comma negative 6. Okay, now what I have to do is in this equation I have to plug in the stuff what we got over here. So y negative, let me write over here, y negative. So the value of y1 is negative 6 equals to the value of m is 5, x negative, x1 is negative 2. Okay, let me write it. Y negative times negative will become positive. That is positive 6. 5 times x negative times negative will become positive 2. So this is the equation of the tangent line to the graph of y equals to x negative x square, and also it is parallel to the line y equals to 5x negative 3.